This problem, we got some points graphed. They got D that we're trying to find. And our concern here is, can we find the distance between point x1 sub y1 and point x sub 2 sub y2 on the coordinate plane? These have some specific, I guess not specific coordinates here, right? So that's kind of in the middle, that's kind of in the middle. We don't have an exact thing here. So let's just investigate these 2 points real quick. So point 1 is x sub 1, y sub 1. And point 2 is x sub 2, y sub 2. Now, what I want you to consider here is if I were to draw a horizontal line off of P towards Q until I get to where Q lives. So I'm not going diagonally to it, I'm just going horizontally to it. So I can have that horizontal piece. And then from that point there, I'm going to go straight north to Q, like so. That is a right angle turn because we went straight vertical, or straight horizontal to straight vertical, right? So just by creating a horizontal piece towards Q and then a vertical piece up to Q, all of a sudden we have a right triangle, where D is the hypotenuse of that right triangle, and these 2 sides that we have marked here are the legs. The second thing I want you to consider is this. The distance from here to here, from P, let's call this point here R, just to give it a name. The distance from P to R is how far it is from x sub 1 to x sub 2. And mathematically, we want to find out how far things are. In a number line scenario, we subtract, right? And we typically take the bigger one minus the smaller one. So if Q is farther right, it's bigger. P is farther left, it's smaller, right? So bigger x, smaller x. So I do x sub 2 minus x sub 1 equals a leg length. So that's this one down here. X sub 2 minus x sub 1. Using similar logic, if I want to go from point R to point Q, I want to find out how far that distance is there. That's simply how far apart the y coordinates are. Y2 is the top, y1 is the bottom height, right? So we're going from y1 up to y2 in a straight vertical climb, right? y2 bigger, y1 smaller, so the other leg should be y2 minus y1. And then, of course, the hypotenuse is called D. So I've got leg 1, leg 2, and hypotenuse identified as something. I've got a bunch of variables in this problem, but it is what it is. All right. And they want us to write a formula here to represent how long D is. So here's how it goes. I'm going to say x sub 2 minus x sub 1 squared. Now, since x sub 2 minus x sub 1 is a binomial, I have to put in parentheses, treat it as one object. And I'm going to have plus y sub 2 minus y sub 1 squared, other leg squared, equals hypotenuse squared. Now I want you to imagine having actual coordinates, right? So P and Q, instead of giving you x sub 1 and y sub 1 and x sub 2 and y sub 2, they give you 3, 2 and 5, 7, right? They give you actual numbers. So typically, when we see a problem like this, where we're trying to figure out how far apart 2 points are, we're going to know the coordinates of P, the coordinates of Q, which means we're going to know this value, this value, this value, this value. What we won't know is what D equals, right? So what I want to do is get a formula representing what D equals. So if D squared equals all that stuff, D is going to equal the square root of all that stuff. And that is the distance formula on the coordinate plane for distance between any 2 points on the plane, no matter what those points are. For example, suppose I gave you a P of 3, 4 and a Q of 7, 7. Right? So this is the 2's and this is the 1's, right? Sub 2, sub 1, right? So I'm going to get the square root of, it's going to be 7 minus 3 squared 7 minus 4 squared equals D. 7 minus 3 is 4, right? 4 squared is 16. 7 minus 4 is 3, 3 squared is 9. 16 plus 9 is 25, square root of 25 is 5. So these 2 points are 5 spaces apart. So again, we create a formula to be able to use that formula in a specific situation.